Hello once again, South Africa and the whole world. Maski Learning and Maski TV are yet again to meet with you. Grade 12, we're not going to waste time with you because we know you're very busy while you're preparing for your trial examination and you have started somewhere. So let's see here. Today we are focusing on the very nice topic, Euclidean geometry. Let's hit the ground. Okay, so at the end of this session, we need to be able to determine a known angles that is given on the cyclic quadrilateral. Remember, the cyclic quadrilateral have three things that you must know. An exterior angle of a cyclic quad equals to the opposite interior angle. We have opposite angles of a cyclic quadrilateral as supplementary. We also have the angles of the same segment, or the angles that are subtended by the same chord, or equal chord subtend equal angles. We need to know how to use the equal angles results that we find in any circumferences as well, that we can use the chord to justify them. As I said, equal chord subtend equal angles. Okay, we also need to be able to apply our tan chord theorem, or anytime we see tan, we actually try to look for it and go with it. In most contexts, when we are teaching, there's something that we use, and it is Dr. Cape Town. So this is actually just an abbreviation that has been used, or that has been used by many teachers for us to summarize what we can and what we don't have. So there, what is actually happening here is that you just try and describe what you have. For example, D then will stand for your diameter, your given diagram and all that. So just make sure that whenever you see a diameter, you remember that D stand for that, while R stand for your radius and all that. So if you have radius or you don't have it into the space and you know what you need to do, remember all of this is just a summary of all the theorems that we have, while then C stand for your center, your circumference. Everything that starts with C is what we use here. So we can make sure that we use them like that. And we have P that actually stand for our parallel lines. So just make sure that you remember, if you see any parallel lines in the shape or on the shape, you can be able to work with. And our last one, and that is T, stand for our tangent. So you just check if I have a tangent and if I don't have a tangent. And also the third one for C will be there for if you have a chord. So this is literally the summary of the theorems that we use in a cyclic quadrilateral, or in the circle theorems. All the theorems has to be aligned with all this. Please make sure that you can remember them with their converses. Converse simple means when you are doing something that you are not given. So you are proving that this is a tangent while there was no tangent, and then you call it a tan chord theorem, but that has to be a converse. All right, with all this, we always have a base of where we are starting. So remember, the basic is whatever that we learn, it starts with some other errors that has been done by other people. So the question paper that we'll literally focus on today, which is a part of what we are going to do, is on the 2024 November exam paper with some mistakes and misconceptions that were done, and we found this in the diagnostic report, right? So they did say that when we deal with this question, which is one of the questions we are going to do, learners were treating things like ECD. So you can see that is our line that is here. They treat this line as a tangent, whereas that line is not a tangent. So be very, very careful of what it is that you say it's there and how you're going to treat them, right? Again, they end up saying that the angle that they find here as A1, they literally say it's 86. For how did they read it is because they think that this is a triangle, and if we have this triangle there, then that becomes an exterior angle of a triangle, which is completely not true, because if you look at it, that triangle there does not really show the line EC as an extension. So it's not extended, or it's not produced, as which the language will say it is produced. So be very, very careful of things like this, right? Some took opposite angles of a cyclic quadrilateral be equal rather than make them supplementary. Do you guys remember what that means? So supplementary simply means that when we add two angles, they literally gives us 180 degrees. So instead, what they do, they come and say angle D is equals to angle B, which is not true. So never ever say this because it's not allowed. What you need to say is angle D plus angle B must be equals to 180 degrees, which is your supplementary angles. All right. So please make sure. Then the other error that we have found in the same question was that they treated C1 as an exterior angle of the triangle, which I just showed you now in the previous slide. And they also go with assumption. So they go and say, okay, AB, since I can see, what you can see is not always the concept of math is all about. So they can say, I can see that these two lines are parallel, and therefore they conclude it's parallel. That is not true. It's either it has to be given to the statement for you to say it, or prove it with reasons. Then we will trust, we will believe you, right? Another one, they said that C2 it's equals to A1 without proving. So let's see which one is that. So let's say they're saying C2, which is this angle here. They said it's actually equals to the angle there without them proving and without a reason of them saying that they're equal. To make matters worse, without them being given a diameter, they went and say that this is a diameter for them, and that means that that angle there is equal to 90 degrees without any reason, because this is not given to be a diameter. It's just given to be a line AC, so you cannot conclude that that is a diameter. So please look out for that and make sure that you don't repeat the same errors that were done by other people. Okay, now as we are doing that, we know that there's many things that we need to learn over and above this a channel that we are, which is Maski TV, which I dare you to actually subscribe so that you can see more, you can get more. We can always assist you at any point. There's videos, there's previous topics that have been done with the previous lessons, the pre-recorded videos that you can use in Maski TV and make sure that you can understand what you need to understand. So let's work together now. As we are working together, we are starting to solve the problem. Remember, we are mathematicians, so we always have a room to solve problems. All right. As you're looking at that question, I am just going to look at it with you together and you do your summary. So this is how I teach. I always say before you even look at the questions, you see there's no questions here. Go to the question paper, read what is given, analyze, annotate, and then go read the question. See you right back. Stay tuned. As always, while you're busy analyzing this, let's just go back one more time. So we had a question where they were asking, why are we saying that angle C1 is not an exterior angle of triangle ADC. So let's do this. So I'm going to just try to highlight the triangle we are talking about, and then highlight the line that has that particular angle, right? So that is where C1 is. So every time we talk about an exterior angle of a triangle, we need to have a triangle like that, like that. So you see, if I have a triangle ABC, which is extended to D, so can you see what is happening here is that if I say this is C1 and that is C2, so an exterior angle of this triangle will be C1. But that becomes an exterior angle of a triangle because this line BC has been extended. It's a straight line. But if you go back and you check your line, EC, it's not the straight line that goes with the triangle that we are talking about. So it is an extended line for the other triangle, which is ABC. So triangle ABC is the one that is an extended angle. That's one. Another thing is that every time you talk about the exterior angle of a triangle angle, which is in this case C1, right? That will be equals to angle A plus angle B, not just angle B, because we're saying the exterior angle of a triangle is equals to the sum of the opposite interior angles. Okay, I hope I've responded to that, and you guys will understand. So let's see what we need to do here. What are we given? What do we have? How do we deal with that to answer the questions coming forward? So always I said, when you see this, the first thing might be, see if you do have Dr. Cape Town. So see if you have this. And if you don't have them, then you cancel what you don't have. You focus on what you have. So let's see. Do I have D, which is a diameter? No, I don't. So this is no. I don't have it. Usually what I will just do is just cancel it so that I don't have to worry about that. Do I have R, which is the radius? No, I don't. And how do you know you don't or you do? When you're reading your statement, when you're looking at your diagram, all these two must communicate and let you know if you have them. Do I have a chord? I do have many, many chords, because look, that is a chord there. This one is a chord. Remember, a chord is a line that is drawn from one point of the circumference to the other circumference. So all these lines which I am highlighting here, these are the chords to this circle. I can actually say S, which is this one. SQ is also a chord, and also we have RP as a chord like that. So I do have a chord, so this one, it's a yes. Do I have parallel lines? I don't see any sign of a parallel lines given to me, and my statement don't talk about anything like that. Do I have a tangent? If you read my statement properly, you will see that they are talking about tangents there. So I do have a tangent. So basically what it means is just that I have two things that I can talk to, or the theorems that has to do with a chord and also the theorem that has to do with the tangent. I cannot say anything about the diameter. I can't say anything about parallel lines as well as radius information now, right? Okay, let's read the question. They said in the diagram PQRS is a cyclic quadrilateral such that PQ equals PR. So when they tell me that, I run to my diagram and I indicate. So they said PQ, which is this line, it's equals to PR, which is this one. Right, so you can highlight that, or you can just go mark what it is. So I know that PR and PQ are my lines that are now equal, which is given, right? They say the tangent to the circle through P and R. So I know that this point here, which are these two, are literally the tangents, or they are the points that allows the tangents to touch the circle. And when I get that, I go back to my brain and say, there's a theorem that they say if there's two tangents from the same point to the circumference, they are equidistant. That is the theorem that we have to think about. And when that is true, if this one here is equals to that, then that means that their angles that are touching through that are also equal. Because because we have an isosceles triangle in this case, which is the same as when we have PR and Q, PR and PQ, which will make these two angles also equal. We're just going to do this so that it doesn't show the same as equal. All right. So these are the information that I have got right now. So I can actually move on and see what I need to do, because the rest, they're just telling me what is produced and what I have and which tangent am I working with, what is intersecting where, and all that. All right. So when I see that, I'm going to say, okay, at this point, I think I'm ready to go look at what I have to look at, which is answering the questions. So let's see. They say prove, giving reason that S, so let's write that down so we can talk to it, that S3 equals S4. So usually when I write this kind of questions, I would work with them as if I am just working with anything from scratch. So I'll write required to prove. So I am required to prove that S3 equals S4. How do I do that? Going back to my information or to what I have been working with, I need to prove or to emphasize that S3 equals S4. So S3 and S4 are just here. So this is what I am looking for. First, you would need to first check what it is that you can do, what it is that you can use to get that right. Can you guys guess? All right. So I do have my quadrilaterals. Let's remove this so we can be able to see. I do have my quadrilaterals. If you check it, this is the one that they told us that is a cyclic quad. I'm just going to highlight it like that. So when I do this, can you guys see that I found S3 outside a quadrilateral? So if you remember very well into my introduction of what it is that you need to know, I said one thing is to learn that the exterior angle of a quadrilateral, which is this quadrilateral. So every time I see this shape when it looks like this, every time I see the shape that has something like this, a four-sided figure, but with an extension like that, it doesn't matter how it looks, I always have just automatically go and say that the angle that I will find there have to be equal to the angle that is there, because that is the theorem, right? An exterior angle of a cyclic quadrilateral equals to the opposite interior angle. But this can only happen if I have a circle around that quadrilateral. All right, so this is the shape I am looking at, and I can see that I do have that shape as I'm indicating here. So that means that my angle, this one, will be equal to the opposite interior angle, which is that. So that will be my first move. All right, so let's do that. My first move will be S3 equals RQP or PQR. Remember to put the head there to show that that is an angle. So I am saying that the angle S3, it's equals to Q, right? The whole of Q. Why? Then I'm going to put my reason, exterior angle of a cyclic quad. So the exterior angle of a cyclic quad equals the opposite interior angle. Right, so that's the first thing I found. And remember, I want to end up with what I need to get as S3 equals S4. So let's see what else can we have. So if you check again here, let's see. If you check again there, you can see that the angle that is S4 there, it's actually equals to R3. But then how is that happening? If I stand on my chord PQ, which is this line, and then I go up, which I usually just use my finger, going up there, it's actually ending its end point in the circumference of R3. And if I do the same, going to the other side of the circumference, but using the same chord, I go to where there's S4, so that means that S4, right, S4 equals R3. So S4 equals R3. What is the reason there? It is angles subtended by the same chord or angles at the same segment, right? So that is angle subtended by the same chord. Which chord are we talking about? Chord PQ. Right? So that is the angle subtended by the same chord. It looks like we are going somewhere. Watch it, let's go. So now when you go back to the statement that was given to us, you will remember that initially I said to you that we are given that the line RP equals the line PQ. So if that is the case, that means that their angles that are opposite, those equal sides, are also equal. So from that information, I am going to then write that, but I know that R3 equals the same angle RQP. So those are equals. Do I just say given? Not really, because saying given, it's not giving us a real statement, although we know that we are given that PQ equals PR. So for us to respond, we're going to say these are angles opposite equal sides. So there are angles that are opposite equal sides. They have to be equal as well. So when you get that, you can see that then it means something. Let's see. I have my R3 there, and I also have my R3 there. So the moment I have R3 equals R3 there in that spot, that means I can actually equate the two, which then will make S4 to be equals to R angle QP, right? Because they are both equals to R3. Then I can conclude, since happily so, since RS3 equals that RQP and also S4 equals RQP, then I can conclude with confidence that S3 equals S4. Voila! I have proven it, and that is how you actually prove. It does get easy as you practice. Every time when you are practicing, it does get easy, trust me. Okay, then the second question, they said that now we have to prove that SMRC is a cyclic quadrilateral. So we want to prove that SMRC is a cyclic quadrilateral. Okay, for us to prove that, we just have to try and get to it somehow. Normally what I will do is I'll try to imagine myself having a circle around that particular shape that I'm talking about. So we said is S, this is where S is, and that's where M is, and we have our R there and our C. So literally what I will do is just put my imaginary circle like that. So if I can be able to prove whatever that I can, which one of it is if I can prove that the exterior angle of a cyclic quad or of the quadrilateral equals to the opposite interior angle, then I have proven it. If I can prove that the opposite angles add up to 180, then I have proven. If I can prove that there's angles that are subtended by the same chord, I have also proven. But looking at this, what does look much easier to get might be the fact that if we try and get our cyclic quad, which I am drawing like that, you can see that if I can be able to extend this line going this way. Can you see that my S4 become an exterior angle which can be equal to the opposite interior angle, which is R1 and R2. So if I can be able to prove that S4 equals R1 plus R2, then I have proven what we have to prove. All right, so let's see how we're going to do that. So if we look at this whole scenario that we have, we already have said that S3 by itself it's equals to S4, right? So if I can be able to get S4, which is this one, to be equal to the whole of R1 plus R2, then we are done. Let's look at it. If I stand on the chord SP, That is my chord. If I stand on the chord SP and I move the way we have been moving, so let's remove that so you can be able to see. If I stand at this chord here and then I move from there to there, and I also move from the same chord to there, you can see that R2 is equals to Q2. But as I said, you need to move with the things that will help you to find both of these two. You see, so if I stand there, I can be able to see that R1 plus R2, both of them, they are between a tangent and a chord. You see, the angle between a tangent and the chord is going to be equal to the angle subtended by that same chord on the opposite segment. So this will therefore be equals to the whole of R angle QP, which is Q1 and Q2. What is the reason for that? It is tangent and the chord theorem. Tan chord theorem, that is what makes the two equal. All right, do you follow that? Hopefully you do, because that is what we are trying to get. Another thing, if you remember very well, we did say that angle, we did say that in the previous one, that R3 is equal to the whole of Q1 and Q2, and also we have proven that S3 is also S4 is also equal to Q1 plus Q2. So we are going to use that now as our strength. So S4 equals RQP. Remember, where did we do that? This was proven above, or we can say proven in 10.1, because we have proved that this is equal. Look at that. So since we have proven that S4 equals to the same angle that R1 plus R2 is equals to, therefore we can conclude that R1 plus R2, they are both now equals to S4, which is what we were looking for. So we managed to prove that these two angles, or the angles that we are talking about here, we have managed to prove that these angles are equal. So we have proved that the angle R1 and R2 is actually equal to the angle S4. Then we can conclude. Okay, so as we conclude, we're going to say, therefore, SMRC is a cyclic quad. We don't just say that and move on. We always must put a reason. I always just prefer to use the converse, right? So that is converse of the fact that the exterior angle of a cyclic quad is the angle that we are talking about. So the exterior angle of a cyclic quad equals the opposite interior angle. So we can say converse of this theorem, or we can say that is the exterior angle of a quadrilateral without us involving circle. Because the time we say cyclic quadrilateral, it means that there is a circle there. And remember, I said that is an imaginary circle. Until you prove it, you cannot say you have a circle. So that is how we actually prove that. A very easy proof, but it needs you to actually know exactly what it is that you are doing and how you are reasoning your solutions. Remember, we did say that we need to reason, so we can't just do it without reasoning. All right. Okay. Then the third one says RP is a tangent. So we want to prove that RP is the tangent. Let's write it down so we can be able to come to it. RP is a tangent which has to pass through what? P, S, and A. Where? At P. So this is just for our notes. Okay, let's go back to the diagram. And then we label that. Okay, so we are saying that we want to prove that RP, which is this line, it's actually a tangent, right? So that is a tangent, but it is a tangent that is passing through some point. So let's see, they say point P, which is that point, and then there's S. Where's our S? There we go. And there's A. So literally what they want us to know, or what it is that we are checking here, is that that is a tangent that is passing through that point, and it has to look like this. So whatever we do for it to be a tangent, there's many things that we need to figure out. First might be that the angle P2, which is this angle there, can be equal to the angle A2. That is one of the other thing. If we can be able to prove that, then we have proven what needs to be proven. All right. So if we can prove that these two angles there are equal, then we are good, because that is the tangent we are focusing on, the angle between the tangent and the chord. And that means that will then be a circle. Right. So let's see. Where do we start? How do we start? Where do we go? That is another thing that you always have to say before you even start doing what you have to do. So if, in this case, remember that we just have proven many other things. So if I can be able to say what is P1, for example, what it is relating to, what other angle that P1 equals to, that can help us go to the answer, and also for me to link it back to the P2 and A2. For every time you try and answer this question, just try to use what you have to answer what you don't have. It's always advisable that you look at that. So if I look at this, this triangle, which I am talking about here, let's use a different color so you can be able to see. You can see that AS has been extended, right? So there is an extension there. So if I come back and I say, okay, if there's an extended, this angle here, which I have there, can be equal to this 2, right? So let's start there. If I say S4, it's equals to A2 plus P1. Right, do you agree? So S4 equals A2 plus P1. Where are we? Are we in triangle ASP? So that is specifically for that triangle. Then we can say the reason will be is an exterior angle of a triangle. So exterior angle of a triangle equals to the sum of the opposite interior angles, right? So that is one. Let's see another one. If I want now to use my S3, let's remove that. If we want now to use the S3, that is where S3 is, because we know these ones. It's easier for us to talk to them because we already know them. So S3 will be equals to, if I use this triangle, I'm just going to try and draw the triangle I'm talking about so that you can be able to see. So if this triangle here, RPS, like that, if I extend it like that or produce, can you see I still have my triangle there? So which means that in triangle RPS, I will have S3 to be equals to the opposite interior angles, which is R2 plus P2. And that reason will be the same, exterior angle of a triangle, right? So this is what I have for now. So if I manage to do that, to find that the angle, some of the angles are equal to others, at some point I'm literally getting excited because I am able to see that my P2, which I'm anticipating to be equals to at some point my A2, I can see it somewhere there. So that gives me quite a joy to say I can see where I'm going. What I need will be just something that will help me eliminate, right? So remember, in the first question, we have proven that S3 is also equals to S4, right? That was our first proof that we have done. So, but because those two are now equal, that make us to have then P1 and also R2. So let's see, where is R2 and P1? So this is P1 and that's R2. If I look at my tangent A, B, P, you can see that this is a chord PS, right? So the angle between a tangent and a chord is going to be equal to the angle subtended on the other side. So can you see that we automatically saying that angle P1 is actually equals to angle R2, right? So we are able to get there. Can you see that? So we are saying that P1 also is equals to R2. So P1 equals to R2. The reason will be tan chord theorem. So that is our tan chord theorem, right? So if these two are equal, which is, let me do this, if P1 and R2 are equal, and also S4 and S3 are equal, what we are then remaining with here is the P1 and the R2, right? So if, or is the A2 and the P2, I mean to say. So we have our A2 remaining as I've highlighted, which will then be equal to the P2. So let's go back to our first thing. We did say that for us to prove that that is a tangent, for us to prove that this line is a tangent, we need to prove something that can help us to get to the answer. So if I can, and that's where I started, if I can prove that the angle A2 is actually equals to the angle P1, then it means I did get to the answer. If I can prove that the angle A2, it is equals to angle P2, I mean to say not P1, P2, which is this one. If I can prove that these two are equal, then it means those are tangent, or that is a tangent, which is what we have proven there. So A2, it's actually equals to P2, right? So we can do a quick recap for you to understand what is going on here. First, when you are given a statement, you need to try and analyze what it is that you can and what you have previously proven, and put it together to get where you want to go. There's a lot of angles here, but you don't want to go through them because they are not relevant to the question. So what is relevant here is the line that you have to deal with, which is the line PR, and also what can help you get to the answer of the fact that that has to be a tangent. So if this is the point that it has to touch, I can either go this way and that way, but I saw that that will take me longer time than if I use the S, which is what I've already proven. So getting to the S is very easy for me because I have proven it before. And I saw that using P1 is also simple because I have already the chord there and the tangent from the original given statements, right? So that is what you actually look at and make sure that you get to what you have to by doing that. So please be careful when you are selecting what you have to use. Please try and make sure that you select according to what you have already proven or what is given for you to get to where you want to go. Right. So for us to be able to say I have an exterior angle of a triangle is simple because I managed to just highlight that and see where the exterior angle is and where the interior angles are. So use your highlighters, use your colors, and make sure that you know all your theorems for where to use them and when to use them, because that is the only strategy that you need to put for you to be able to respond to these questions. All right. If you remember very well, there was a question that I have been talking about. I said last year's question paper, other people were getting it wrong. Other people didn't manage to get it right because of some errors and misconceptions, right? So we are here now looking at that question. Let's do it together. In the diagram, ABC is a cyclic quad. I like it because they've already just told us that it's a cyclic quad, and at the back of your mind, you already have to put all the cyclic quad theorems and make sure that everything that has to do with a cyclic quad is adhered to, right? So they said BC is produced, which just simply means a straight line has been extended, right? And they say AC is drawn, but then we are given information. We're told that A1 equals to half of angle B. It's not equals to angle B. People, is just half of angle B, right? We're told that A2 is 46 and that C1 is 86, right? That one is straightforward. There's nothing much that we can do. The information is just as it is on the diagram. Okay, so calculate with reason the value of A1. Now, we already know that A1 has been given to be half of angle B. What you need to do with that is first find what can angle B be. What is angle B if you can, or use your A1 ideas to get where you want to go. So here, for example, this is my exterior angle of a cyclic quad, right? So this will be equal to the opposite interior angle right there. So exterior angle of a cyclic quad equals to the opposite interior angle. Mind you, when they ask you this question, they would have asked you to prove one of the cyclic quadrilateral theorem. So every time they ask you that question, just put it at the back of your mind and you know that you will have to use it going forward. All right. So answering that means we're going to say, okay, that is what we are given, but it won't really help us a lot. But I know that angle C1 is actually equals to the whole of angle A. So I'm going to say angle A1 and angle A2. Right? They are all equal. Reason an exterior angle of a cyclic quad. All right. So what is C1? C1 is 86 degrees. I am looking for A1. I am given A2, which is 46. Then you just do some math there. Then A1 will be equals to 86 minus 46, which will be 40 degrees. So that is how you can find A1. Very easy and straightforward. Okay. Now, in 9.2, they say to you, hence, meaning use what you have. Hence, prove that line AD, let's just highlight that so we can remember, line AD is actually equals to line DC. So we want to prove that. Remember, folks, when you have to prove that the lines are equal, in this case, we have to prove that the angle A1 is actually equal to the angle C2. If you can prove that, then we are done. So now we have angle A1. We can find whatever that we want to find. First, you can find, if you want, the sum of the angles in this triangle. How are you going to do that? You can first find your B angle, because you know that angle B is actually twice angle A1. So you can start there so that we use the information given to us, right? So angle A1 equals half angle B. So I'm looking for angle B. That means I have 40 multiplied by 2 equals angle B1 or angle B. So that means my angle B is literally 80 degrees. Okay, so if now I know that the angle here, let's remove this. Now I know that this angle there, my angle B is actually 80 degrees, like that. Then I can be able to find my angle C3 from the angles of the triangle, if that is going to help as well. Or you can use any other method. There's quite a lot of methods here that we can use, but due to time, we might not manage them. So we can say in triangle ABC, that is our triangle, angle C3 plus angle A2 plus angle B must be 180 degrees, and that is the sum of the angles in a triangle. We can just say angles of a triangle to be quicker. That is angles of a triangle. Then, because we know what we have, that means that C3 will be equals to 180 minus 80 minus 46. Right. So if you subtract those, you should be able to get to the answer, which is, let me quickly check. That is 180 minus 80 minus 46. That gives us 180 minus 80 minus 46. That should give us 54. So that means that I have my C3 as 54. Now, after you found that, you can actually use the angles on the straight line for you to find the last part, which is your C2. So C2 will then be equals to 180 degrees minus 86 minus 54. And if you do that, then you'll be able to find the answer, which will be, should be 40. Let me just check. So 180 minus 86 minus 54, that should give us 40. Yes, it does. So that is 40 degrees. So in this case, you managed to find that the angle that is here is 40 degrees. It's our A1. Also, our C2 is 40 degrees. And for the fact that we found the angles that are opposite the sides that we are looking for, then that means we have solved the problem. So therefore, we're going to come and say AD is indeed equals to DC. But we need to put a reason just by saying that it is because they are the sides that are opposite equal angles. So that's how you can, one of the way for you to solve this problem is to do it this way, and then you can be able to simplify and make sure that you get to the answer like that. There's quite, I think, 3 or 4 ways to solve this particular question that you can go and practice and get more, that it can help you to get it. So very, very important. You just have to make sure that you always, and this is very realistic, that you always remember your theorems. You make sure that you know what you are looking for and how you need to get to. So if they ask you to find parallel lines, what it is that makes lines different, or what it is that makes parallel lines a parallel lines. So what it is that is not a parallel lines, so that you can be able to get to the answer productively. With this being said, I do believe that you guys have learned and you have managed to get it right, and you can be able to do more and more of the question. Over and above this, if you stay subscribed in Maski TV, you can be able to get this recap of this and many, many more of what it is that we have passed from, or any other video that we give you. In addition, we can pin you every time the lesson is about to start, or anytime that there's new things coming in Maski TV. You will stay connected and you can be able to give us all what you need. And I believe that grade 12s, with this, you're going to make the best of Euclidean geometry. And you see how seamlessly simple Euclidean geometry can be. I believe in you for as long as you believe in yourself, and Maski Miller Learning and Maski TV are here to support you all the time. Stay with us and make sure that you can also go to our Maski and also Maski TV. So Maski TV, it's here to lively make sure that you learn this math and ensure that it's mathing in a productive way. See you next week. Stay with us. Bye.
And now we enter our next exciting chapter with the launch of Maskiverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology.